Thing I'd like to show is the Scala Map class. And so a map, MAP, is a collection of key value pairs where the keys must be unique. And Scala has both immutable and mutable versions of map classes. They also have different types of map classes, and I'll show those at the end of this video. And also what I'm going to show in this video is just the default immutable map. So to create a map, you would just say something like val states equal map, and then open that up there like that. And then a map, again, is a collection of key value pairs. So I would say AL goes to Alabama. And then AK goes to Alaska. And I'll just put those elements in the map and hit return there. So what you can see is that each entry here is a key value pair. So this whole row is one entry, and this row here is the second entry. This is the key for the first one, and this is the value for the second one. And similarly, this is the key for the second one, and its value right there. Now, in this case, both of these are strings. So this one is a string and that one's a string. And you can see that reflected in the type here, where it says map of string to string. If I had created a different map, let's just say val m equals map, and then I could say 1 goes to A, and then 2 goes to B. Then you could see here we get a different type of map, and this is a map of integer to string. So we have 1 to A, 2 to B. So that's how you create a map. And then to access elements in the map, you could do something like this. So you could say states, and you pass in the key. That's all you have to do. So if you wanted, I would go back here and I could say val value equal this. So states is the name of my map, and then al is the key that I'm passing in. And when I hit enter, I get that as Alabama. So now this variable value is equal to Alabama. But you have to be careful with this, because if you accidentally put in the wrong key, you'll get a no such element exception like that one right there. So if you are going to access values like this by passing in a key, one thing you can do is use the get method. So you could say get, and I will pass in foo once again. And then you'll see that that returns an option of type string, and then it's a none. It's a none because foo is not found. But if I put in AL for Alabama, then you'll see that this is a sum, and then the sum contains the string that you want, which is Alabama. And I was hesitating there because that really should, if the REPL was a little bit better, that would say Alabama inside of double quotes like that. That would be a little more proper result right here to show that the sum contains a string. And then another possible approach you could do is you can use get or else. So again, I would pass in foo. Foo is the key that I'm looking for, and then the or else is you put right here. So then I would say not found. So now value equals the string not found in this case. But then if I pass in the correct AL right there, then value is the string of Alabama. So this is another safe approach. Get is a safe approach. Get or else is a safe approach. Conversely, using this approach here is not considered safe because it throws that type of exception. Now, all that being said, I don't typically use these methods as much, because what I use is either a for expression or map or filter or any other higher order function on these. So I'll show a for expression just to show how you can use these. So now I can say val, let's create an uppercase map. So I'm going to say that equals this for expression. And the way you work with maps here, let me type this first. So I'm going to say do that. So the way this reads is I'm saying for every key and value pair in the map named states, then what I want to do is yield the following. And in this case, I'll yield, let's see, the key is already uppercase, so I don't have to do anything there. And then the value, I want to do 2 uppercase right there. And now you can see this creates another map. UC map here is another map of string to string, and now everything is uppercase in UC map. And to go back here, I want to explain this one more time. So I'm creating a variable named UC map, which stands for uppercase map, and I'm saying for every key value pair in that map, I want to yield a new key and value pair. And a key here, now, I guess I'm kind of overloading that word, but this section right here is a tuple. It's a 2-element tuple, and you can tell that because of the parentheses. That's how we write a tuple. So this is for example, this would be a tuple right here. You can see that's a tuple that contains an int and a double. And this happens to be a tuple that I know is a string and a string because I know that the map contains a string for the key and a string for the value. So this is a 2-element tuple, and by convention, I call them k and v for key and value. And then I use those variables. So both of those are variable names right here. And then I use those variable names in the yield block down here. So here I say I'm going to yield another tuple, again by the parentheses that open and close that. And then the key is k, and then the value is going to be v, and then I convert that to uppercase. So that's the way for expressions work. And again, by convention, I use k and v, but if you have more meaningful names for your map, by all means, go ahead and use those. And just to be clear on that point, so this could be abbreviation, and then this could be the full name, or let's say the state. And so then I would change that down here, and this would be the abbreviation, and this would be the state. And there you go. And also I can show a different approach here because I mentioned that I use either for expressions or I use higher order functions like map and filter and so on to work with maps, as opposed to I don't normally use get or else or get. So what I could do in this case would be, let's see, what am I dealing with? States. So then I could say states map, and I'll put a space here to make that a little bit easier to see. So now I'm going to say for every key and value pair, transform that key value pair into this new key value pair. So that's going to be k and then v.to uppercase, and then yield that right there. And so now this map method call right here is the same as this first for expression up there. And again, I spoke as I was doing that, but again, this is a tuple. So you're saying for every key value pair in the map, transform that key value pair into this new key value pair, and then yield that result. And that result here is, the uppercase version there. And then you see the uppercase names here. So that's how you'd use a map method. Similarly, I'm calling map there. I could also call filter before I call map, just to get rid of the things I don't want. So then I could say filter, and again, this would be for every key value pair. I want to filter out, what do I want to filter? I want to retain the ones where the key is equal to al. So now you can see how that works. So I have the map here, which is my map of states. The first thing I do is I call filter, and I do what I just said. I want to take a look at every key value pair and only keep the ones where the key is equal to al. And then when you finish getting that map out of filter, go ahead and call the map method like I did the first time. And again, that says take this key value pair and then transform every value to uppercase, and that yields this result right here. So that's an example of how to chain together a filter method followed by a map method. Now, going back to this original map, I've shown so far how to create maps and then how to read elements from maps. And now I want to show how to update, or in this case, add elements to a map. So I'll say, what do I want to do here? So I want to do, this is an immutable map. So I need to assign a result to a new map. So I'll call this states2. And I'll say states. And the first thing I'll do is show how to add a new key value pair here. So I would say Colorado, or CO maps to Colorado, like that. So then you can see that result over here is I've added CO and Colorado as a new key value pair to the map. And then if you want to add multiple values at one time, or I'm sorry, getting ahead of myself, I use the plus symbol here. So use plus when you want to add one element to a map. And now rather than you having to watch me type all this stuff, I'll show that, again, I use the plus symbol to add one element. When you want to add multiple elements, you use plus plus, and then you add a new map to this existing map here, and that gets you a new result. So now you can see this new result has all of these map values. And so that shows a little idea of how to update maps. And now to show how to delete elements, we'll say states4 equal, and then I could say states3. And the way you work with this, if you want to delete one element, you use the minus symbol. and then you specify the key that you want to delete. So I'm going to delete the entry for Alabama. So here you can see in the previous variable, I had Al pointing to Alabama. And now if you look through this data, that entry is gone. So you delete one element like that by specifying a key that you want to remove. And then if you want to, oops, that's easier to do it this way. If you want to remove multiple values, then you would say val states 5 equals states 4. And then here use a minus minus when you want to remove multiple values. So then I'll say I want to remove Arizona and I want to remove Arkansas. And then I'm down to this map here. So again, delete one element with a minus, delete multiple elements with minus minus. And the nice thing about these is that everything I just showed with the plus here, the plus plus right there, and then the minus and the minus minus, is these are all very consistent with all of the mutable collections. So by that I mean list, vector, seek, and then the map that I showed here, the set class, all of these use the same symbols, plus, 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 minus, and minus, minus, in the exact same ways that I just showed here. And earlier in this video, I mentioned that there are multiple types of maps. So there's a mutable map, which I just showed. Then there's also a mutable one. And, that one allows you to update the elements in place. And as I scroll through this article, this is on my website, and I also put this in the Scala cookbook. The problem here was that you wanted to choose a map class for a particular problem. And then as I go through the solution, I show how to sort maps, and I'll show that more either in this class or in the following class. So I show how to sort by keys here and by values here. And what I want to do is I want to keep scrolling down. So this shows the basic map class. So the default map class is this one. It's the immutable one. And as I mentioned, there's also a mutable one. So immutable and mutable. And then you get into these other types. So there's a linked hash map. There's a list map. In Scala 3, either in Scala 2.13 or Scala 3, there became a vector map. And again, I'll cover that more in the advanced course. And there's a sorted map, which is one way to sort elements. And then as you scroll down here more, you'll see more descriptions of different types of maps. So you may have seen in the REPL that once I started adding many elements to a map, it turned into a hash map. There's a couple of other types of maps here. So down here, I note that there's even more types of maps. And some of this information is a little old because this was written for Scala 2.10 and 2.11. So in the original Scala cookbook. And the newer Scala cookbook, which was released in 2021, provides updated information about all of these types.